Hello everyone. Today we're going to be learning about OR and gates. So on the left hand side of your screen right here is an OR gate. Now they're sometimes represented by this, but either one, these guys are interchangeable, so either one will work. And then on the right we have an AND gate. So first let's look at OR gates. So OR gates, or this one in particular, has two inputs and one output. So this output will be high if either of your inputs are high. So if X is low and Y is high, your output will be 1. If X is high and Y is low, your output will be 1. And if they're both high, they'll be 1. For an OR gate, the only case where the output's low is if all of the inputs are low. So this is the truth table for a 2-input OR gate. Now, the characteristics carry over for even, say, a 3-input OR gate. If any of these 3 inputs are high or logic 1, the output will also be high or logic 1. And the only case where the output will be 0 is if all of these inputs are 0. Okay, so let's take a look at a CMOS circuit example. So 0, 0, 0, 1, 1, 0, 1, 1. Okay, let's go through the 0, 0 case first. So if we apply 0 at all of these transistors, these top 2 transistors will be off, so no connection is made here. These bottom two PMOSs will both be on, thus connecting the ground up into here, and then to the gate of this PMOS down here, which, since we're connecting ground to it, this transistor will also be on, thus connecting out to ground. Okay, so 0, 0 results in an output of 0. Now if we do 0, 1, where I guess I should label X, Y out. So if Y is 1, this transistor's off, this transistor's on, this transistor's off, this one's on, which connects VDD to this net here, which then goes to the gate of this NMOS, which is then turned on, and that connects your output to VDD, giving you an output of 1. Now if we do 1, 0, again, this transistor will be on, connecting VDD to this net. This transistor's off, this one's off, and this one's on. So again, you have VDD going to the gate of this transistor here, which turns on and connects out to VDD. And then the final case, if they're both 1, both these transistors are off, both these transistors are on, connecting VDD to the gate of this transistor here, turning it on, and that again connects your out to VDD. So notice how it's got the same behavior as the OR gate we just looked at. All right, now moving on to the AND gate. So the AND gate will have, in this case, again, 2 inputs, 1 output. And the AND gate outputs a 1 if and only if both of your inputs are high. So this is what the truth table for an AND gate, a 2-input AND gate, looks like right here. Okay, now let's say we had a 3-input AND gate. The only way that this AND gate will output a 1 is if all of your inputs are 1. Otherwise, it's going to output a 0. Okay, and you can see how for both the AND and the OR gate, regardless of how many pins, the behavior still holds. All right, now let's take a look at a CMOS example. So X and Y, 0, 0, 0, 1, 1, 0, 1, 1, and our out. Okay, so for the 0, 0 case, we apply zeros everywhere. These top 2 transistors are off, no connection is made. These bottom 2 are both on, connecting ground to this net up here, which then goes to the gate of this PMOS, which turns that on and connects your output to ground, resulting in an output of 0. Now for 0, 1, we apply a 1 at Y. This transistor's off, this transistor's on, this one's off, so there's still no connection made from VDD to either of the gates of these guys. However, this transistor down here in the bottom left is turned on. So there's a connection from ground to the gates of these two rightmost transistors. And since it's ground going to the PMOS, this PMOS will be on, and again, out is connected to ground. Now, flip side, 1, 0. This transistor's off, this transistor's off, this one's on, but again, we need both of these two NMOSs to be on in order for VDD to get connected to this net down here. This PMOS is turned on, connecting ground to this net, which then goes to the gate. This PMOS, again, connecting your output to ground, results in another 0. Now, finally, if we apply 1, 1, both these PMOSs on the bottom are off. Both these NMOSs are on, which finally connects VDD to this net here, which then goes to the gate of these two NMOS and PMOS. PMOS is off, NMOS is on, connecting your out to VDD, giving you an output of 1.